Right now, at this very moment, you're moving through space at a speed of nearly 1.3 million miles per hour. You don't feel the motion. You don't see it. There's no vibration, no wind, no sensation at all. Yet Earth is racing around the Sun. The Sun is orbiting the center of the Milky Way. And the Milky Way itself is hurtling through the universe, pulled towards something massive, unseen, and deeply mysterious. For decades, astronomers noticed something strange. Galaxies all around us were drifting in the same direction. Not randomly, not chaotically, but flowing like leaves caught in a cosmic river. That river pointed toward a hidden region of space, concealed behind the brightest and densest band of stars in our sky, the Milky Way itself. At the heart of this mystery lies what scientists came to call Great Attractor, a gravitational influence so immense that it outweighs hundreds of quadrillions of suns. A force powerful enough to pull entire clusters of galaxies across millions of light years. But the strangest part? For most of human history, we couldn't even see it. Tonight, we begin a journey through one of the greatest cosmic investigations ever conducted, a 50-year hunt across the universe to uncover what lies behind the Great Attractor. For centuries, humanity believed the universe was static. Stars were thought to be fixed points on a celestial sphere. Galaxies were island universes, isolated and unmoving. That illusion shattered in the 20th century. Astronomers discovered that the universe is expanding. Galaxies are moving away from one another. Space itself is stretching. But expansion alone could not explain everything. When scientists measured galaxy motions precisely, they found something unexpected. Galaxies weren't just drifting outward, they were streaming. Entire groups of galaxies were moving together, deviating from the smooth expansion of the universe. Our own Milky Way, along with the local group of galaxies, is moving at over 600 kilometers per second relative to the cosmic background. That motion is not random. It has a direction, and that direction points toward the constellation Centaurus, deep behind the Milky Way's bright disk. To understand how astronomers detected this motion, we must rewind to one of the most important discoveries in modern science. Finding the source of that pull was far from easy. The problem lay directly in our line of sight. The Milky Way is filled with stars, gas, and cosmic dust. From Earth, it forms a bright band across the sky. Behind this band lies what astronomers call the Zone of Avoidance, a region where visible light cannot easily pass. Galaxies hidden behind it were invisible to traditional telescopes. It was like trying to map a continent while staring directly into the sun. For years, the universe simply vanished in that direction. But science does not stop at obstacles, it adapts. In the 1970s and 1980s, astronomers began using infrared and radio wavelengths, which could pass through dust. Then came a groundbreaking effort. A group of astronomers, later nicknamed the Seven Samurai, began mapping the motion of thousands of galaxies. They measured galaxy distances and velocities with unprecedented accuracy. Their conclusion was unavoidable. Galaxies were flowing toward a massive gravitational center, roughly 250 million light-years away. They named it the Great Attractor. But even with new tools, the Great Attractor itself remained elusive. It did not appear as a single object. There was no obvious supermassive structure visible. Something far more complex was unfolding. Early theories proposed dramatic explanations. Was it a supermassive black hole? A collapsed region of space-time? A hidden exotic object beyond known physics? The numbers were staggering. The Great Attractor exerted the gravitational influence of 100 quadrillion suns. No single object could account for that mass. As observations improved, a new picture emerged. The Great Attractor wasn't one thing. It was a region, a massive concentration of galaxy clusters, superclusters, dark matter, and hot gas. At its heart lies the Norma Cluster, one of the most massive nearby galaxy clusters ever discovered. But even the Norma Cluster alone was not enough. The gravitational pull extended across vast distances, forming something much larger. This realization led to one of the most profound discoveries in cosmic cartography. In 2014, astronomers redefined our place in the universe. By mapping galaxy motions instead of just positions, they identified enormous cosmic flow patterns. These flows revealed that the Milky Way is part of a vast structure called Laniakea. Laniakea means immeasurable heaven in Hawaiian. It is a supercluster spanning over 500 million light-years and containing more than 100,000 galaxies. Within Laniakea, all galaxy motions converge toward the same basin, the region of the Great Attractor. For the first time, humanity had a true cosmic address. Earth's solar system Milky Way local group, Laniakea supercluster. But even this was not the end of the story, because Laniakea itself is not alone. When astronomers extended their maps even further, they discovered something unsettling. Beyond Laniakea, galaxy flows did not stop. They continued, moving toward even larger, more distant regions of gravitational influence. Some flows seemed aligned across billions of light-years. This raised an extraordinary question. Is there something beyond the Great Attractor? Something influencing the motion of matter on the largest scales imaginable? This idea became known as dark flow. Dark flow suggests that galaxy clusters may be moving toward structures outside the observable universe. If confirmed, it challenges fundamental assumptions of cosmology. Is the universe truly uniform at the largest scales? Did conditions beyond our cosmic horizon influence the early universe? Could unseen regions of space still be shaping our destiny? While dark flow remains controversial, it reminds us of something essential. The universe is bigger, deeper, and more mysterious than we ever imagined. Every discovery raises new questions, and every answer reveals how small, but how connected, we truly are. Could humanity ever reach the Great Attractor? The short answer is no. At our fastest spacecraft speeds, it would take billions of years, far longer than the sun will survive. And even if we could arrive, there would be no single object waiting for us. No cosmic monument, no center point, only a vast, beautiful web of galaxies, bound together by gravity and dark matter. The Great Attractor is not a destination. It is a reminder that motion is fundamental to the universe, that even galaxies drift, that nothing, not even space-time, is truly still. And as we move forward, carried by forces older than stars themselves, we continue our journey, unaware, unstoppable, and endlessly curious.